education and collective tier of the 30-agent architecture, we cross a threshold. Agent 28 modeled a single, hidden human mind. Now, with Agent 29, the collective intelligence agent, the focus shifts to coordinating a multitude of specialized minds. For complex, multi-objective problems with genuine trade-offs, any single reasoning model inherently possesses blind spots. A solitary intelligence cannot reliably grade its own logic. The standard engineering instinct to solve this is brute force. You spin up 5 identical copies of a large language model, feed them the exact same prompt, and take a majority vote. That naive approach to collective intelligence completely fails when applied to generative AI. The mathematical basis for crowd wisdom is the Condorcet jury theorem. It proves that if each juror has a better than 50% chance of being correct, a majority vote approaches perfect accuracy as the crowd grows. But that theorem rests on one load-bearing variable: independent probability. The jurors must make their mistakes in different directions. Large language models share identical pre-training manifolds and alignment biases. Their errors are highly correlated. They err together. This creates a phenomenon known as confabulation consensus. A naive vote doesn't average out hallucinations. It actively reinforces and validates a shared hallucination. Extracting the actual wisdom of the crowd requires mechanically forcing epistemic independence into a system that naturally wants to agree. Most multi-agent systems are designed as open-ended chat rooms where agents talk over each other. True collective intelligence requires a deterministic, multi-round protocol. The design philosophy of the collective intelligence agent is that the solution to correlated errors is engineered disagreement. Looking at the consensus engine architecture, the first step is abandoning clones. The system impanels a jury with strictly defined, conflicting specializations. In Phase 1, the protocol forces these agents to submit round 0 independent proposals into a shared repository before seeing anyone else's work. Isolating the agents during this initial drafting phase mechanically prevents anchoring bias. It establishes the baseline diversity required for Condorcet's theorem to hold. With the initial proposals logged, the architecture actively attacks them in Phase 2, the critique phase. The engine uses a rotating critic mechanism. Each round, one agent is assigned as an adversarial critic to aggressively find flaws. The agents then cross-evaluate proposals, casting numerical scores against a strict rubric measuring correctness, completeness, and risk. The rotating adversarial critic acts as an automatic groupthink prevention mechanism, guaranteeing every deliberation round contains a dedicated skeptic. Returning to the consensus engine flowchart, Phase 3 is convergence and synthesis. The system runs a mathematical tolerance check on the score dispersion to decide if consensus has been reached. If the scores are too dispersed, the agents cross-pollinate, update their shared context, and refine their proposals through a strictly bounded loop. When it is time to finalize the decision, the engine applies this gatekeeper equation, expertise-weighted scoring. This prevents an agent from having undue influence outside its assigned domain. The ultimate output is a verifiable, audited synthesis no single agent could have authored alone. This bounded loop translates multi-agent collaboration from a rhetorical concept into a reliable, enterprise-grade logic engine. Implementing this protocol carries a massive computational overhead. Running a multi-agent consensus engine can inflate token costs by anywhere from 58 to 285%. This architecture is highly inefficient for simple data lookups, basic code generation, or latency-sensitive tasks. The correct deployment targets are high-stakes architectural design reviews, complex strategy formulations, or problems with unforgiving trade-offs. The collective intelligence agent acts as a calculated insurance policy against the expensive blind spots of a single intelligence. Agent 29 represents the absolute ceiling of coordinating minds within a purely digital sandbox. The final step for this series is taking these synchronized agentic workflows and pushing them out into the physical world. That brings us to the series finale, Agent 30, the Embodied Intelligence Agent. This consensus architecture and its theoretical framework are drawn directly from Chapter 15 of Imran Ahmed, exclusively available on Amazon and Pact. Visit neuralsca for the full code repositories and start impaneling your own AI juries today.